Hey, Algebra 2 folks, how we doing today? Alright, looks like my camera's finally working here. Alright, we've got y equals kx, just a quick review. Do you remember what that is? That's a direct variation. And so if we solve for k, divide both sides by x in this case, we know that the relationship for k, that constant of variation, is taking the y value and dividing by the x. Now when we have this k over x, the inverse variation, when we solve for k, multiply both sides by x, we get the product of those two coordinates equaling that constant of variation. So we're going to take a look on our graph paper here and see what this function looks like. I'm just going to do the most basic there is, which is 1 over x, the constant. We'll play around with that changing in a little bit. So if I drop a negative 3 into here, I get negative 1/3 for my y. And then if I put a negative 2 in here, I get a negative 1/2. Put a negative 1 in here, I get a negative 1. Now here's where it's a little strange. When I divide by a fraction, so I'm dividing by negative 1/2, what's really happening is I'm saying how many halves are in 1. And so the answer for that is 2, and it's negative. So remember, doing 1 over something, that's the same thing as dividing that denominator into 1. So how many thirds are in 1? That would be a 3 and negative. Now here we can't do it. Putting a 0 in, that's undefined. So what's going to happen is we're going to have some asymptotic behavior, kind of like what we're used to seeing in those exponential decay and growth problems, but certainly a little bit different. As you can see, I've got some other values. I wanted to make sure that I have some positive values as long as with the negative ones. So now if I put a 1/3 positive in here, how many thirds are in 1? I get a 3 again. 1 divided by 1/2, that gives me a 2. 1 divided by 1 gives me a 1. 1 divided by 2 gives me a 1/2. So you can see there's some symmetry happening here. Now if I go and graph these, I'll put some graph paper on Seesaw for you, if you like mine. And I'll graph these points. So if I go to this first one here, negative 3 for the x, and negative 1/3 for the y. So there's that point right there. Negative 2 gives me a negative 1/2. Negative 1 gives me exactly negative 1. Negative 1/2 gives me a negative 2. Negative 1/3 gives me a negative 3, and etc. You can see how this is going closer and closer to the y-axis there, and closer to the x-axis there. This is called excuse me, this is called one branch of the curve. And so the second branch is in the first quadrant. That's these positive values. So now if I go to 1/3 positive for the x all the way up to 3, 1/2 gives me a 2. 1 gives me 1. X being 2, I get a 1/2. And x being 3, I get a 1/3. And so you can see this is the second part or second branch of this curve. And there's some symmetry happening. We'll talk about the identity line, that y equals x line cuts that in half and it's symmetrical. We also have the y equals negative x. And so if we put a minus sign in front of here, it's just going to flip the quadrants. So this is quadrants 1 and 3 for a positive k, and we'll find out, yeah, it's just going to reverse it and put the curves in quadrants 2 and 4 if I have a negative k. So that's kind of the first one, graphing. You can use your graphing calculator to help you out with that. Then the second part of this section is talking about similarities and differences between these types of graphs. I'm just going to make some notes here for you. Get that up there. So you might have noticed we've got asymptotic behavior in the curves. Whoops. And they're going to both axes. So actually the two axes are asymptotes. So that's one similarity in all these graphs. So axes are asymptotes for both branches. So if I wasn't clear earlier, because it's got two separate curves for this graph, whoops, can't see what I'm pointing to here. It's got two separate curves, so those are each called a branch. So two different branches of this function. All right. And then there's symmetry. With respect to those two identity lines. The y equals x and the y equals negative x. And then one thing that's not as clear is the smaller the k value, and that's just the number part, so the smaller the absolute value of k is, the closer it gets to the origin. The closer the graph is to the origin. For example, if I had y equals 3 over x instead of 1 over x, that curve would be further away from the origin. Differences, not a lot, but there are a couple things. If the k is positive, then like I mentioned, we're in the first and third quadrants with our values. If the k is negative, then we're in the second and fourth. And now, where it intersects. So where the curve intersects that identity line, oops, that's not an E there, intersects the curve, we would have y equals kx, where y is x, or x is y. So if I take out the y and put in the x, it's the same thing. I get, whoops, that's over x. Excuse me. Then it's going to be k over x equals x, because y and x are the same thing. If I multiply both sides by x, I get x squared equals k, square rooting both sides. That tells me that I'm going to get x equal to plus or minus the square root of k. I could do the same thing for the y's. So let's say, all right, I'll put an x in for y. Whoops. A y in for x. Got that backwards. And then solve for that. Same way. I'd get y squared equals the k, and same thing again. The y is going to equal plus or minus square root of k. Where it hits that identity line, that is the closest it gets to the curve. Okay, and the value of it would be square root of k for that ordered pair on the positive, or it could be negative square root of k and negative square root of k if it's on the other branch. Not a huge point of emphasis this, but that is a little bit of a difference. Where that intersection point is that square root of k. All right, that's the first half of the lesson, major part of it. Second half now talks about translations with this stuff. And the nice thing about that, it's pretty much the same as what we've been doing. So translating these things, whoops, let's get that so we can see it. There we go. So this is kind of, these are example 4 or 5 and 6 questions, I believe. The previous were examples 2 and 3. If you look at page 486, and 7, you'll get a good idea of what's going on with those problems. All right, so y equals, now we're going to do k, the general, x minus b plus a c. And so this is going to translate much like we're used to. The x part translates horizontally, and the c part, that's the up and down, the y vertical translation. Now here, x equals b, when this zeroes out in the denominator, that becomes the vertical asymptote. So x equals b is the vertical asymptote in general. And then, like you might have guessed, y equals c, that's the horizontal asymptote. Oops. Spelled that wrong, didn't I? Dang it. All right. Let's see if I can do it right this time. All right. So they're going to give you an equation and ask you, what's the slide? So here's 1 over x minus 2, for example, minus a 3. And they would say, first of all, how is that parent function slid? How was it translated? And if you are familiar with this still, it's 2 to the right. What zeroes it out? That's going to move it 2 to the right. And this is going to also slide it 3 down. And then it'll also ask, well, what are the asymptotes? So what are those asymptotes? Let's see if I can spell it right this time. There we go. And it would be x equals 2 and y equals the negative 3. All right, one last thing, and that is basically reverse this. All right, so here's the parent equation, negative 7 over x. And then it's going to ask, what is the equation if x equals 8 is the vertical asymptote and y equals negative 4 is the other asymptote? So it'll tell you these are asymptotes. I spelled it wrong again. Can you make the equation for it? All right, well, if I'm x equals positive 8, that means I'm going to have to subtract 8 from x. That minus 7 is still in the equation, and then it's sliding down to negative 4 on the horizontal, so it's minus 4. And there you have it. All right, this assignment, a lot of graphing, page 488 to 90. It's numbers 2 through 32 even, and 53 to 57. Have a good day. I'll talk to you soon. Take care. Bye.